Hello, in this video presentation I'd like to show you some of the other things I get up to. This morning, and it is 6:41 and it's a Sunday, I'm off to watch one of my learners who's trying to get recognised under the competent person scheme so he can Part P register himself, and there's a level 3 course that he's currently working his way through, and part of the course requirements is that he's seen on site installing wiring systems in a domestic dwelling. So I'm off to see him this morning. So let's see how that looks. Once he gets a little bit lighter and I turn up at the installation, I'll introduce you to the guy we're working with and we'll see what he's up to today. So I'm setting off now to obviously get to the on-site visit. It's remarkable, isn't it? I've got a rucksack full of camera equipment, I've got tripods, etc. You know, the last thing I'm thinking about is a set of screwdrivers and tester. They're obviously already in my vehicle, but it's amazing how times have changed. Hopefully we'll get some decent footage today and we can see what Marcus is up to. I believe he's doing a consumer unit change. And before I get a shout out from everybody out there, he's also got somebody at work who will sign that off under the competent person scheme. So he's got a qualifying supervisor who will sign off his job for him. So it's not as if he's changing the consumer unit domestic dwelling without having it signed off. Let's go and see what Marcus is up to. So I'm here with Marcus. He's one of my domestic installer students at level 3 and he's currently in the process of changing the consumers unit. And we said earlier, before we start shouting at me, that we can't just go in and change consumers without notifying the work. It will be a notifiable job. His QS in his company will notify it on behalf of the company. So we're halfway through the change of the consumers unit. Before we actually even started doing the consumer unit changes, were there any tests that you carried out beforehand?
Yeah, I did some insulation resistance tests just due to the fact that I'm adding RCDs and I didn't want to energise the circuit and there'd be loads of earth faults on the circuit which would trip the RCDs. I also did my loop test, my ZS tests on all the circuits just to prove that the new circuit breakers, BSCN 60898, that I'm changing for the BS3036 rewirables, would meet the correct disconnection times.
Okay, and you also said to me you did some continuity testing dead and you found some issues on the ring final circuit, is that correct?
On the kitchen ring final circuit, I found that I had no continuity between my CPC conductors in the board. So when I investigated further in the sockets, I found the CPC had broken at the top, so I had to repair that just to bring the continuity of the CPC back to the circuit.
Also, we looked at the bonding before the job started because obviously if there are any issues with bonding being missing or incorrect sizing, you'd have to quote and replace for those. Did you find the bonding was in place?
Yeah, the bonding is in place with the correct safety connection tags as well present.
So, as we're looking from the outside in, it's not just a case of simply changing the consumer's unit for a brand new one, Amendment 3, metal, dual RCD, etc, etc, that we've gone through a series of pre-tests before actually doing the work itself. If any of those pre-tests failed, we had to sort the ring out, the bonding wasn't in place, we had a load of earth faults during the installation resistance. They're all things that need to be resolved before starting the consumer unit change itself. We're at the stage where they've all been resolved and we're halfway through the consumer unit change, so we're going to see a little bit of Marcus perhaps connecting up the consumer unit and then some of the tests that he's going to carry out when he's gone live. So what test are we carrying out now then, Marcus?
Now we're carrying out our first dead test, which is the continuity of the circuit protective conductors, including main and supplementary bonding. Okay, and which circuit we're going to start with? We're going to start with the cooker circuit.
And you've linked that out to the earth bar, I see. So the line and the earth bar are connected together.
Yep.
And we're going to go off and do the continuity test.
I've zeroed my test leads. I'm carrying out my continuity of my circuit protective conductor in my cooker circuit. So I'm going to probe onto the line conductor in the cooker connection unit at the back of the cooker and onto the back of the cooker as it's an exposed conductive part. I get a reading of 0.71. Now to prove polarity, which is another dead test while I'm here, I'm going to flick off the cooker switch, probe back on, and now have an infinite reading. So carrying on from my continuity of my circuit protective conductor on the lighting circuit upstairs, I've worked my way around all the upstairs lights and switches, leaving the switches in the on position for the later insulation resistance test. I found my last point, which I also found in my pre-tests. So now I'm just going to test at the last point where we should obtain the highest reading. Going on to my CPC and my line conductor. Get a reading of 1.68. I'm now at the light fitting. I'm just checking between my CPC and my switching line. I get a reading of 1.46. Now I will operate the switch to prove polarity, that it switches. Now I have an infinite reading, which proves polarity. We found our highest reading was 1.64 on the upstairs lighting circuit. Now we're going to return all the covers back to where they were due to the insulation resistance test. We're also going to leave all the switches in the on position and remove the loads because we don't want them to affect our insulation resistance reading. Carrying on from the continuity CPC, we're now doing the shower circuit. I'm at the shower point. I'm going to probe onto the line and the CPC. I get a reading of 0.09. It is a bit of a low reading, however, the circuit does go straight down. It's not a very long run, a 6mm cable. The resistance in the cable is going to be low. Now the shower switch has been switched. I've proved polarity because I have an infinite reading at my shower. Carrying on from our continuity of our circuit protective conductor test, I'm now doing the immersion heater circuit. So I've gone onto the actual tank of the heater for the CPC to prove continuity, and I'm on the line conductor. Get a reading of around, let me give it a scratch, 0.22. Now I'm going to switch the switch to prove polarity. I now have an infinite reading which proves the polarity switch. In the switch, as it contains a neon, I've disconnected that so it doesn't give me any false readings for my insulation resistance test on this circuit. Just at the final point of our lighting circuit for the downstairs, doing the continuity of the CPC still. I've probed on, I'll get a reading of 0.73 ohms. Now I'm going to prove polarity, pull in the switch. Now I have an infinite reading, and if I pull it again, I have my resistance reading back. Now moved on to the second dead test, which is the continuity of the ring final circuit protective conductor. First of all, I'm going to probe onto the end of my line conductors and prove continuity. This is proving that there's a continuous ring around the circuit. Get a reading of 0.15. Now I'm going to probe onto my neutral conductor. Again, 0.15, which is what we would expect, as there's the same length of cable. Now I'm going to probe onto my CPC. This should be 1.67 times greater than the line and neutral conductors because it's a smaller size, therefore there's more resistance. And it is 0.45, which is around what we'd expect.
So we're taking our end-to-end readings, little r1, little rn and little r2. Can you just explain to Marcus what you've done with those readings for me?
So now I've done my end-to-end tests. I'm now doing my figure of 8 tests. And I've calculated my big R1 and big Rn by little r1 plus little rn divided by 4. That will give me a reading of 0.075. I'm allowed a plus and minus of 0.05 either way of that reading at each socket outlet and at the distribution board. Now we've got our calculated reading. In the board I've linked the opposite line to the opposite neutral in connector blocks. That's for our figure of 8. I identified the opposite legs when I removed the old consumer unit and put the new one on. I'm now going to test across the connector blocks to get a reading which should be within 0.05 of my calculated reading, which is 0.06, so it is. I'm now going to swap my leads over. I'm now zeroing out my plugged lead so I can carry on with my continuity of my ring final circuit and my figure of 8 test. I've got this bit of kit here. You simply just click it on, just between the line and neutral, as that's what I'm testing between. So I've used the blue and red into the back of the tester. Now I've zeroed my leads, I'm going to go around to all of the socket outlets on this ring and I'm going to plug into each socket, proving polarity and continuity, part polarity, part continuity on the way. 0.08, which is within our 0.05 fluctuation. Just check polarity. I'm going to leave that in the on position for the further insulation resistance test, so the insulation resistance comes to the front of the plate. 0.09 as well. Infinite reading, switch it on. 0.09. Leaving it in the on position again. Infinite reading, switch it on. 0.11, which is still within our 0.05 fluctuation. Now we've finished the first part of our figure of 8 test, we're going to move on to the second part, which is our big R1 plus our big R2 equals our little r1 plus little r2 divided by 4, which gives us the reading of 0.15 ohms, which is slightly higher due to the CPC being a slightly higher size. First we're going to zero our lead so we can test in the consumer unit between the connector blocks. they're zeroed. After zeroing my leads, I've come back to the consumer unit where I've now linked my opposite line and my opposite CPC together in a connector block, as I did with the line and neutral. I'm going to test in the consumer unit first, just to prove that my reading is within the 0.05 of my calculated reading of 0.15. I've got 0.12, so it is. Now I'm going to put in my plug-in tester and go around the sockets. Before I go around to my sockets and test for my values, I've changed my lead to a plug-in lead test, so I've just got to zero that. So I've zeroed that between the line and the CPC connections on the plug. Now I've zeroed my leads, I'm going to go around my socket outlets, and now I can fully confirm polarity and confirmation that it is a ring final circuit. 0.12, polarity confirmed. 0.14, polarity confirmed. 0.16, again polarity. 0.18. All were within our 0.05 fluctuation of our calculated reading. All the breakers up. I've torqued the breakers to the correct settings with my torque screwdriver. I'm now going to do the main switch, so I'm just going to check on my paperwork to see what torque setting it should be. On here it says it should be 2.3 Newton meters, so I'm just going to adjust my torque screwdriver to the correct setting. There it is. I'm going to torque it up, and when it's torqued you should hear it click when it's at the correct torque. There we go. That's that torqued up. Now we're ready to carry out the insulation resistance test. Even though I've torqued up all my breakers, main switch and my earth and neutral bars, once I've completed the insulation resistance test, I will then go around and just double check to make sure everything is torqued to the correct setting before we go live. I've just got to connect the 16mm squared earthing conductor to the supply authority's MET before I carry out my insulation resistance test. We've now moved on to our insulation resistance test. I've made sure all loads are out of the circuit, i.e. lamps, neons, anything plugged into the ring circuits. All RCDs are turned off because they have electronic components in, so that could be damaged by the DC voltage from the tester. The smoke alarms are battery, so we don't have to worry about them because they're not wired into the circuits. I'm going to go between line and neutral first, as the NIC domestic installer paperwork allows me to do so. The BS7671 actually only allows you to do between live conductors and earth, where we would have to link them together. We don't have to in this case. So I've set my tester to 500 volts DC. I'm going to probe onto the neutral bar for this side of the RCD. And then on the top of the breakers, 500 mega ohms. 500 mega ohms and 500 mega ohms. I'm now going to move on to the other RCD, which is a different neutral bar. So same principle, 500 mega ohms, 500 mega ohms, 500 mega ohms and 500 mega ohms. That is the line and neutral insulation resistance test. Insulation resistance, we're going to go on to the second part, and we're going to do between line and CPC. Same principle. There's only one earth bar here, so we don't have to worry about disconnecting, putting onto a lock we did with the neutrals. Again, 500 volts DC, which is going to go across all the top of the breakers. We're now on the next part of the insulation resistance test. We're going to go between our neutral bars and our earth bar. So we're going to go on the first neutral bar for the first RCD. 500 mega ohms. Second bar for our second RCD, and the earth bar, 500 mega ohms also. We're now going to go on, we're going to swap all the strappers around on the two-way lighting circuits and redo the insulation resistance to check that other side of the strapper. We're now going around switching our two-way lighting circuit so we can check the strappers. So I'm going to switch that one, but I'm also going to go to the top of the stairs and switch this switch into the other position. Now we can retest our insulation resistance. Now we've been round and switched the strappers on that lighting circuit, we're now going to do insulation resistance just on that lighting circuit to prove the strappers. We're going to do the same combination, we're going to go between neutral and line. Yep. I'm going to go between neutral bar and earth while we clamp it on, 500 mega ohms. Now we're going to go between the earth bar and the line, and again 500 mega ohms. That conducts our insulation resistance test. We're now going to recheck the polarity of the supply. With that I'm going to use a voltage indicator and a proving unit. I'm just going to prove my voltage indicator is working, that's fine. Now we're going to check it. We're going to go on to the least dangerous conductor first, that being the earth bar in this instance, and then to the top of the main switch on the line conductor. When we have voltage, we're going to come off the most dangerous, then off the least dangerous. Now we're going to do between our neutral and our earth, so we're going to still go on to the least dangerous, which is the earth, and the most dangerous in this case would be the neutral. And we find we have no voltage, which is what we should expect. We're going to come off the most dangerous, off the least dangerous. Now we're going to go between line and neutral at the top of the main switch. We're going to go on our least dangerous first, in this case being the neutral, our most dangerous being the line. We have voltage off of the line and then off of the neutral. We're now doing our external earth fault loop impedance test. For this I've removed the main earthing conductor from the board. This is to eliminate the parallel earth paths. I've also switched the insulation off by the main switch in the board, just in case anything becomes live under fault conditions. While we have this removed, there would be no earthing to it. We're going to clamp on to our earthing conductor, and in the top of the main switch we're going to go onto the line conductor and receive a reading of 0.19 ohms. That is satisfactory because we have a TNCS earthing arrangement and the maximum ZE for that is 0.35 ohms. We're now carrying out our prospective fault current test. For this we put the main earthing conductor back in the board. This is because we now want to take into consideration the parallel earth paths. First of all, we're going to check again the PFC against the main incoming fuse. It's rated at 60 amps. However, we looked on the side, there is no breaking capacity rating. However, we do know they range from 16 kiloamps to 33 kiloamps. We're going to take it from the lowest end, the worst case scenario. So first of all, we're going to clamp onto our main earth bar and into the top of the main switch we're going to do our prospective earth fault current, 1.2 kA. I've got to switch my meter around because we're going to do the prospective short circuit current, which is between line and neutral. And for this we're going to go on to the top of the main switch. .507 amps. So we take the worst case scenario for them, which was the 1.2 kiloamps, so that will be our PFC for the main incoming fuse. We're now going to check our PFC for the top of the breakers. So for that we need to energise the circuits, and we're doing this so there's no loads on while we energise the main switch. So as you can see, everything is off, and then one by one. Now we've energised all of our circuits, we're now going to do a PFC for the top of our breakers. When we was installing them, we looked at the side of the breaker in this case, and they are a breaking capacity of 6 kA. For this, because of RCDs in the circuit, I'm having to do a 3-lead no-trip test on my tester for when we do our PFC and PSC. So first of all, we'll clamp onto the earth bar. I'm going to go on the neutral bar, on the top of the breaker. This is for the prospective earth fault current. Gives us 1.2 kA. Now if we switch the tester over to line and neutral, this will give us our prospective short circuit current, which is 1.1 kA. We're now performing our earth fault loop impedance test, otherwise known as a ZS test. In this instance we're using a 3-lead no trip test because we have RCDs in the circuit. We do know we can calculate this measurement by doing our ZE plus our R1 and R2. However, at college we have been taught as long as we take the necessary precautions, i.e. GS38 probes, then measurements are always the best way forward. First of all, I'm going to probe onto my earth terminal. Now if we check this value, 0.87, we know that's well within the limits as a 6 amp breaker has a maximum ZS of 5.87 ohms. I've now completed the ZS test for our other lighting circuit. We're now going to do the shower circuit. Again, a 3-lead test due to the fact of an RCD being in the circuit. We probe on. We have a reading of 0.28 ohms. We will check that in our on-site guide for the maximum ZS values for a 40 amp breaker which the shower is on. We're repeating the same test now for our cooker circuit. So I've clamped onto the back of the cooker for our earth. So onto line and neutral. Oh, slipped off. 1.05 is our reading. Carrying on, we're now doing our ZS on our ring final circuit downstairs. We're using a plug-in lead tester this time. .37 ohms. We're going to do both sides of the socket as well. 0.36 ohms. We'll then check the values against our maximum ZS in our on-site guide. .42. Again, both sides. .41. Now we've completed our loop tests, we're now going to move on to the RCD tripping time tests. On this particular test I'm going to use the auto function, so it will test it at half times, 1 times, 5 times on both sides of the cycle, 0 degrees, 180 degrees. So all I have to do is to press the test button, do its thing, and we just have to keep resetting. Now it's finished, we come back to our tester, and as you can see we can scroll through the readings. Now that I've completed all my tests other than my functional tests, I've got a label at the board and I'll do this alongside my functional tests. So what I'll do is I'll break the main switch and go around and check that all the circuits have been isolated, and then I will use my test button on my RCD. I'll check the circuits that haven't been labelled yet. I'll check then, just them ones have gone off. I'll re-energise that. I'll then test this RCD, do the same principle with them circuits, and then as I'm labelling them, I'll individually go around and check that they all isolate the correct circuit.
So me and Marcus today have tried to show you as many on-camera tests as we possibly can. We tested one of the lighting circuits off camera, we tested one of the ring final circuits off camera. So we try to show as much as we can and obviously condense the video down as best we can. It's now down to the rest of my domestic installers to prove that they can carry out these tests. His QS will come in and complete his paperwork and obviously retest the circuits. We hope this video has been some help.